everyone, welcome to the class. As all you know, the topic of this week for the Tools for Sustainable Communities class is energy. And it's my great pleasure to introduce our guest lecturer, Professor Paul Parker, an Associate Dean in the Faculty of Environment and the Director of the Economic Development Program, with more than 2 decades teaching and research experience in the green economy. Professor Parker's work on the development of win-win strategies for environmental and economic achievement has led on numerous projects focused on renewable energy, energy efficiency, net zero homes, and so on. Professor Paul Parker also works with engineering colleagues and as the specialist of policy, behavioral, and community dimension of the energy transformation. Please give him a round of applause.
Thank you. I already have a microphone. Thank you very much. Of course, I have a confession. I have been working in this field since I was in your shoes. When I was an undergraduate, I had this favorite project. It was called the ARC. It was a house that was solar powered and wind powered, and I thought, wow, this is the future. You know, so I talked to the people there, I talked to the neighbors to see what's going to happen. Maybe you know, what happened to the ARC? Was it the future that the next generation of houses was going to bring us? Has anybody heard of the ARC? I confess, I'm from the Maritimes. This is a small house on Prince Edward Island. And if you go and visit the site now, you would never know it had renewables near it. After the owners moved out, they tore down the turbine, took off the solar panels, and converted it to an ordinary house. Ouch. I feel I should apologize for my generation because we lost a great opportunity, and you know the global consequences. What have happened in terms of our Canadian or global emissions over that last 25 years? Have they gone down as we hope? No. Have they gone up? Absolutely. So, I have news for you. Your job is even bigger than my job. I mean, if our generation had started acting then, we said it would be easy. Everybody knows when was the big international conference recognizing the importance of climate change and policy intervention? When did that big conference happen? Where did it happen? This should be a moment of pride for Canada. The Toronto Summit brought the scientists and politicians together in 1988 to say we have to take action on global climate change. It is real, there's no question. And what was their proposal? They said it's simple. If we reduce demand, the energy intensity by 1% a year, and we reduce the carbon intensity by 1% a year, that'll give us a 2% reduction. So over the decade from 1990 to the year 2000, we'll already be 20% lower, moving in the right direction. Wonderful idea. But did it happen? No, you've seen our greenhouse gas emissions. Why not? It sounds simple. Just give me 1% on energy intensity and 1% on carbon intensity, and we'd be going in the right direction. Why didn't it happen? Well, they ignored the drivers on that equation because it's also driven by our growing population and our growing economy per capita. So even though we were good in some years, in fact, in a few years there in the 1980s, we actually did get a 2% reduction, but we had even bigger economic and population growth. So although in per capita terms we were improving, as a country, and it's also true as a planet, we were still seeing net growth because of the increased population and economic drivers. So we really needed to have like 4% per annum reduction. And why am I talking numbers? How many of you think we should take no action on climate change? No action required. None of you. Oh, so we all agree we should take action. How many think we should take action? Oh, very good. How many of you think community energy planning is a good part of your action agenda? Community energy planning sounds good? Good, most of you, okay. Have any of you been involved in community energy planning? Some, a couple, nodding the head, that's good. Because of course I would suggest this is one of the big career opportunities for planners because the drivers of change are getting louder all the time. My generation tended to ignore these issues. We can no longer ignore the issues, but even better than that, people are making different decisions now. What's the year I like to circle on the calendar? I shouldn't give you test questions at the beginning. You should all know. You are planners. What do we have to do? We have to have energy for people. We use energy in all forms of our development. If you look at the world's biggest energy markets of Europe and North America, I like 2008 as an important year. Why was 2008 important? In 2008, what was the largest source of new energy brought online in the biggest energy markets of Europe and North America? 2008 marked the first time when renewables exceeded conventional fuels. Before that, they had said, yeah, you can have your wind turbine, or yeah, you can have your solar, but these are small, they don't really matter. In 2008, they became over half of the new capacity installed. Wow, it's no longer insignificant. So what happened in 2009? Anybody guess what happened in 2009? Was it just a blip? In 2009? You're anticipating, I'm scared. Was it a yes, a repeat or not? Yes, it was a repeat, absolutely. Wow, we've got 2 data points. 2 years in a row, renewables exceed conventionals. Great. Well, what happened in 2010? 2010, are we going to get a three-peat 3 years in a row? In 2010, the same thing was true for the global market. So we have seen substantial growth, not only in the developed, but also in the developing countries. So now the largest investment is actually taking place on renewables. Why? Or I guess I should check. Did the same thing happen last year? Are we still working in this direction? The answer is yes, absolutely. We are now talking about hundreds of billions of investment. This is a huge industry that is accelerating. Why is that the case? Planners, you think of the big picture. Why is there more investment in renewables now? Somebody must have a good reason. It's not because Paul thought it was a good idea. Somebody else thinks it's a good idea. Yes?
Is it because of the market drivers there? Because people are realizing like that's making more market right now?
Yeah, so market drivers are absolutely true, yes?
I think there's also a lot of more physical evidence that this is a real thing to worry about, and that we need the environment and time to be separated from the environment.
So we have the environmental evidence, absolutely, yes?
Like creation and installation has become cheaper because more people want it, and has a proven investment track record that pays off.
Absolutely right. Do you know how much have we seen the drop in price in solar panels as an example? Any idea?
That's a lot.
It's a lot. It is enormous. Do you want me to give you a personal example? But when I put solar panels on our house, sorry, I have to give you a little confession first. I've got very bright daughters. They check on what I'm doing. And so I was going to put the solar panels on the house. And so I'm an academic as well, so I actually did the calculations of how much will it cost, how much will we save over time. And I show my 11-year-old daughter the answer, and you know what she does? She looks at me and she says, Dad, you're going to be in the old folks' home. What was our payback period? It was going to be 50 years. She's a smart girl. She's absolutely right. But things changed a few years later, and the government introduced new policies. So this was back before there was a feed-in tariff, before there was a RESOC program, which was the government's program before the feed-in tariff. So this is back in 2005. And so, yeah, it was going to be a 50-year payback period. Now, fortunately, the new policies turned into an 8-year payback period, so that was much kinder of them. But the finances have changed fundamentally, so that when I priced and put in the new panels now, an 80% reduction in the price. How many things, drop by 80%? We used to pay more just for the installer than we do now for the whole equipment and installation. So it is cheap. How cheap? Yes, it's the cheapest in many parts of the world. Wherever you look, who's winning the contracts? You go to India. And say, okay, what's going to be the next source of generation? The latest bid, coal was undercut by wind as the cheapest source of electricity. This is not just let's get rid of the carbon. This is just how can I get cheap electrons onto the grid? Wow. So we have seen an enormous reduction in the prices. How reliable is the technology? Reliable is the technology. We sometimes talk about, going back to the 1970s, the future world, Disneyland put in these solar panels, and 40 years later, over 90% of them are still operating. 40 years later. Of course, my experience is just one, so it doesn't really count, but in my house, 13 years of experience. What's my repair bill being for my solar panels? Maintenance, repairs. 13 cold Canadian winters, stressing out these Japanese panels, and the total repair bill is $0. If I was how much did I pay for gas at the same time? It was not $0, right? So these are reliable as well as lower cost technologies. So I think this is the generation where we are absolutely seeing change. So I have news for you. I am going to ask you to think about the future rather than the past. Surprise, you are all planners. And so this to me is the beauty. We've got a challenge. The title of the course is Tools, so I'm going to point out some different software and organizational options to work with. We want to transform what we do with our houses, transform what we do with the grid, and if you don't mind, I'd like to take you on a little trip up north because I'm Canadian and I like our north as well. I know most people live in the south, but we have important changes in all of these communities. I had to submit an abstract to give you a rough idea of what I was talking about, but my plea is do not wait. Sorry, what did your boss? You've got a planning job coming up, and they say, yeah. The American and Canadian Associations of Architects have agreed. 2030, all our buildings will be net zero. Don't worry about it. Have you seen the crime that is committed in Toronto? Sorry, I love John Straub, one of our engineering colleagues. He's a building science guru, and all of the glass towers in Toronto frustrate him to no end. Why? Because they are as energy efficient as that 1800s farmhouse with the wind still blowing through it. They are an insult to our society. Of course, the good news is they are all illegal if they were built now, but they got earlier planning approval. There is a big delay between when something gets approved and when it gets planned. So as soon as they put up a flag and say in 2030 we're going to have new standards coming in, guess what? You're going to have a lot of applications in 2029 trying to get in under the old rules. Why wait? What I'm asking for is, I guess, first, is it feasible now? Or do we need to wait until 2030? Is net zero feasible now? You're nodding your heads? Absolutely. In fact, it's already an old news story. What was the meeting I was at before coming here this afternoon? We're planning the Evolve building on the North Campus. Anybody heard of the Evolve building on the North Campus? Good. Can you tell me about it? Anything we should know about it?
It's going to be the most sustainable office building in North America, and it's planned to be.
Yeah, and so why is it the most sustainable?
I think, I'm not sure on the specifics, but it makes its own energy, and it's just built in a way that keeps everything in insulation.
Absolutely. And so it's saying net zero is old news. It's going to be net positive. So what is a net zero building to start with? Net zero means?
It doesn't consume any additional electricity from the grid.
That's right. So it doesn't consume net. So it does, of course, consume energy, but it also produces energy. So that we have a balance between the demand and the supply side. So it's net zero over a year's typical period. Absolutely right. So to go further, this evolved building says, yeah, we're not going to be net zero, we're going to be net positive. So in other words, it will generate more than it actually produces, or generate more than it uses. So it's a net plus. So they talk about being net positive is one term. Another term, as planners, when you're talking to your architectural friends, you'll hear is regenerative. The idea of giving back to the planet rather than always taking from the planet. And it's the same for water and air quality, and I think put in brackets, if we can train the people, waste as well. So that the four areas, obviously today I'm here to talk about energy. So it is focusing on generating more energy than it consumes. Wow. To me, that is important. There are different definitions of the term net zero. We started with the easy and typical one, and that is how much did you use this year, how much did you generate this year. If you want to talk more about sustainability, should we go further? How about the energy embedded in building? Like that first net zero definition is our operational energy. How much did we use for the lights and for the heating this year, today? But how did we get the building here in the first place? We also want to think about the embedded energy it took to actually build the materials and put it together. So for life cycle analysis, we often now talk about net zero carbon, including offsetting the carbon that went into the construction of the building. So that is what can be achieved by this type of net positive building, because it's not only meeting its operating needs, but it's offsetting the construction needs and ultimately the demolition or repurposing. Of course, what's important for all of you, please plan for long life buildings. Rather than short ones that'll be torn down in 10 or 20 years. There is a problem with how quick we put up the blocks and then tear it down. Let's think long term. We have the tools, and oh yes, they are financially viable now. Wow. That's a strong statement. What's the evidence? One of the tools that your instructor noted in your readings was LEAD, so leadership and energy and environment. What do LEED buildings, how do they make money for their LEED owners? Do you know, how do they make money if I have a LEED building? And how do LEED buildings perform? How do they make money for their owners? Suggestions?
Because it's like high performance, high efficiency, you're not spending that additional money on your utilities or on cleaning your air and things like that. And so that's like savings right off the bat.
So you actually have lower operating costs, and that's sort of one of the first areas that people first look at and say, in these buildings, the number one cost is people, by far. Far more than 10 times. It's big money for everybody, all these employment operations, paying your people. And energy is often one of the bigger, but it's a factor 10 smaller. And so we can save money on energy, that's good. But what makes even more money for LEED-owned buildings? LEED-rated buildings make money because people like working in them. that means that they actually have a much lower vacancy rate. And when somebody moves out, somebody else moves in faster. So even if you're charging the same rent, you're earning more revenue over time because the space is always occupied. And that's actually an even bigger factor when you look across the American experience, is people want to be there. And whether that's, you like the natural lighting in this building or whatever your criteria are, and oh yeah, it does happen to save you money. It does mean that if people are going to be there, it's easier to get the loans to finance the building, etc. So good. Any questions about LEED? Have I persuaded you? I think you're a very kind group. You're nodding. Is it agreed this is a direction we should go in? Can I take you through a set of slides? Again, this is reference material for you to use afterwards. You're not going to be tested on everyone. But my plea is start now. And yes, I do try to do the same in my personal life as I teach. So I've been, experimenting with solar panels and improved energy efficiency in housing for a long period of time. And yes, I've also just built a net zero carbon house that you can do. We have all the technology now. We do not need to wait. Wow. How do we get there? Oh, they even put the 4 steps right here in front of me. This is the US Green Building Council. They've got it all lined up. So what do you need to do? The easiest way, the cheapest form of energy is reduce your consumption. Step number 1 right here, reduce your consumption. If I use less, then that's pretty cheap to supply that. Number 2, that high performance building envelope. Not a surprise in Canada, we know insulation is a good thing to have in our buildings. Step 3, appropriately designed systems. If you want to put a ground source heat pump in your building, guess what? They will say the first thing you need is an energy model. Why? Because if you reduce your energy consumption, you have a smaller system to build to supply the energy. So it's balanced and appropriately sized. Many of our builders use the rule of thumb. How big is your house? This is how big a furnace you need. It's a rough rule of thumb, and you go, yeah, but mine's more efficient. It's only going to be on for a few minutes. The furnace is not as efficient then. It doesn't get up to its proper temperature. It goes on a bit, off a bit, on a bit, off a bit. And it's a much more wasteful system than having it appropriately sized. So appropriately sized is good. And then on-site generation. We can do that as well. So these are the 4 steps. Green Building Council. Makes sense. Look at that leafy green roof and house. Maybe your house doesn't look exactly like that. Some would say this is too bright and shiny, too many rooms. So you say, well, okay, put it at has anybody seen the net zero houses over in Guelph that Reed's built? Anybody been over to see them? They look kind of like this because, this is their website. Except, what did they do when this is the first house they built. They had to get enough solar panels on the back building. What did they do for their second house? As planners, you want to know, how can you get more solar panels on and make them a little more discreet? Rather than having a balanced peak, they just lowered the slope of that roof to give them a bigger south-facing area and put more panels on top so they didn't need to have them down below. And people don't mind when they don't see it. In fact, I should confess, I have ugly solar panels. I'm a bit of a, actually it was my daughter helped me put the panels on our house. And I'm lucky. I live in Canada. We've got nice big maple trees. And guess what? They provide shade. Solar panels don't like shade. So I know I lose about 17% of the potential energy because of shading. So I, also being at the university, know, what can I do to improve the output of my house? I put my panels on an adjustable rack so I can put them up steeper angle for the winter and a lower angle for the summer because you want to have them perpendicular to the sun to get most energy. So mine are not nice and at the same slope as the roof. I actually have a racking system that they're flatter now, but in the winter they're at a steeper angle. So a planner might call them quite ugly. So when I was being asked to speak to a local community club about my experience, and this is of course over 10 years ago when everybody knew these things were terribly ugly. And what? The guy in partway back, he said, you've got solar panels? I go, yeah, I've got solar panels, but I live 2 houses up from you. Yeah, we're neighbors, that's right. And you walk the dog past my house every day, you know, and never even saw the solar panels on the roof, right? You know, so maybe not so ugly, you know, if you've got a few trees around. So the aesthetics might not be too bad. But this, they just simply flatten it back, give more roof facing the south, and away you go. Good solutions. And do we have just one net zero builder nearby? I like the story to say no, there's competition. Sure, Reed's Heritage are good, they built 5 over in Guelph. Sloop, also in Guelph, also building net zero, so their first house sold well, so what do? They're putting in 52 townhouses all net zero. This we can do now, have been doing for years. This is not demonstration anymore. Now let's take it to the main market, okay? This is no longer radical. What's also no longer radical is the greenhouse gas emission pattern for Canada and our targets of where we need to get to. So this, of course, is part of how do we get there. This is my reminder that energy and power sometimes use the terms interchangeably. They are not the same. Energy equals power times time. So 1 watt equals 1 joule per second. So if we want to talk about a kilowatt hour, that equals 3.6 megajoules, and the joule is our measure of energy. So how much energy is are we going to be using? I don't know, what would use 100,000 megajoules? That sounds like a big number. 100,000 megajoules is about the amount of energy a new house would use. Again, it's all about prefixes. If you want to get rid of 3 more, about 100 gigajoules a year is what a new house now would be built. And why don't we cut it to 50? Good question. I want to talk about the entire energy system. So this is the interconnection of all the different components. It's not just, can I turn the light on? It's what's behind that light. So I want you, as good planners, to think about the whole system that we are bringing to bear. And we'll look at some examples and think about the supply and demand side. And of course, green infrastructure is core to this. We don't need to use the same practices as before. You want to go shopping this evening? Of course, you want to go down to the store, but then you say, how do I get there? And the form of transport determines the type of energy. So if you're taking the car, it's going to want the gasoline. You want the gasoline, that means something's happening at an oil field. So you're having this energy line, but really it was just, I want to go shopping. And it starts this whole sequence. The same is true if you just say, well, I just want to turn on the light so I can read or watch the video or whatever. Well, that means I need a lighting device. I need a source of that electricity, and that takes me back to some power station. Perhaps it's Niagara Falls, a hydro-based, or perhaps it's coal-fired. You know, so we need to think about the whole system, not just the first step of, you know, I just press the button in the elevator. What happens when you press the button in the elevator? We should put a big warning sign there. It's something I've been thinking we should be doing for a long time. And say, warning, you are about to use, 1 kilowatt hour, or whatever the amount is of electricity, because it's this big motor that kicks into gear at the top of the building to spin the cable to pull it up. Versus, oh yeah, I guess I could walk up here instead. So we should, inform our consumers. So we go from saying, what is the action, going shopping or turning on the light, to what is the associated energy system. And if you were in my energy course, of course, I talk about this slide for an entire year because it's my favorite. Why? This is the entire Canadian energy system. It starts with the demand. You want to have food, housing, commercial, institutional, industrial, transportation, all of our different demands. But on this side, we've got the different supplies, the different sources of energy. We choose different lines, different technologies to convert from one version of energy to the next. This means you have choice. You can match the demand on one side to multiple options over here. It doesn't have to be, as you see at present, dominated by coal, natural gas, and oil. That doesn't have to be our answer. There are many technical connections. So think about the whole system. Yes, we want to meet society's demand, but there are many ways that we can do that. So let's plan from beginning to end. Canada. Are we good? Or are we not so good? Sometimes you'll hear politicians stand up and say, oh, but we're tiny, we're in Canada, the world's got all of this energy it's using, we're just little. Yeah, but we're even smaller in terms of the number of people. If you look at it in per capita terms, we are, wait a minute, 5 times the global average. So there's always a be careful, different people use different numbers. You know, yes, we might be small, but that's because there are 30 million of us, you know, out of the 6 billion, 7 billion in the planet. But per capita wise, we are some of the larger energy consumers. Where does that come from? Simple conversion. I like my black coal. Well, I must. I'm human. And when was coal king? We've heard about coal being burnt and used for energy. We talk about the industrial age. When did we humans use the most coal? When did we humans use the most coal? No idea. Was it the 1700s when we started these steam engines? The 1800s when the railroads really took off around the planet? 1900s we started burning it for power stations? The 21st century. We have never used more coal. Coal is king today. We are using more coal than ever before. Oh, this is a practice we need to change. Fortunately, you are global leaders. How are you global leaders when it comes to talking about coal-fired power station? Coal, it's very simple. You throw it in the boiler, it gets hot, the water boils, the steam drives the turbine, runs a generator, and you get electricity coming out. Pretty simple. So what have you in Ontario done with this simple, well-proven technology?
You got rid of it?
You got rid of it. You said thanks, but no thanks. It used to supply about 1/4 of our electricity. And you go down the big Nanticoke plant down on Lake Erie shoreline, it works just fine, but there are consequences. And so the government said, no, we want to get rid of coal-fired electricity. Wow. Well, what was the consequence of that? Were there any impacts that we can measure or identify? Did it have any impact before? Remember I talked about our energy intensity and the carbon intensity. So did it change the carbon intensity of our energy supply system? Coal is great, but you bring in this carbon, it combines with the oxygen, and you get the carbon dioxide going out, as well as a small amount of other both contaminants and emissions. So much so that burning coal becomes one of the world's biggest sources of mercury being released, or other heavy metals, even though it's a small amount per ton. Because we burn so much coal, small amounts of these minerals are released, and that gives us significant air and health problems. The electricity goes from that power station on high voltage transmission lines to step downs to come down to our customer level, where here it's 120 or 240 volts. Anybody know why we take it up to such a high voltage on these high voltage transmission lines? Is there a reason for that? There must be some kind of reason. It's part of the debate between using alternating and direct current.
Is it because of the higher voltage that there's like less losses in the lines?
Absolutely. Higher voltage is less losses because there's less current. So it's the current, the actual electrons moving along, that actually heat up and cause losses. So higher voltage, you'd have less current moving for the same wattage. So absolutely right. Higher voltage for less current to have less wasted heat. So that's why, and alternating current, it's very easy to have transformers to raise the voltage. And so it is a good system that way. Energy losses. Well, what do you mean, energy losses? I just wanted to, drive. So final energy, the energy that we're going to use, we talk about, well, I guess we were talking about how much energy does our building use? That's how much I need to supply here. But if I get it from the electricity grid, guess what? There were losses in transportation or transmission and conversion getting it to us. So when we come back over here, the amount of resource that's required is larger. We talk about final demand energy on one side and primary or resource energy on the other side. And because people like making U-turns all the time, they also talk about it as source versus site energy. Site energy is how much energy are you using on site. Source energy recognizes you need more energy at the start of the system because some is lost. Oh, this is getting complicated. I know, but we're students. We love this. This is why I have a confession. Okay, I'm biased. You might get a sense of that. I love the European approach to measuring their passive house standards. What do the Europeans do when they measure the energy requirements and the energy standards for their housing? I understood the Americans, Canadians, we're talking about net zero, that's easy. Produce as much as you consume, got it. The Europeans say, not so fast. We want you to think about not how much energy you're consuming, we want you to think about the primary energy, how much energy had to go into the system to get it to you for your final demand. So as an academic, we go, actually, the Europeans are right. Because it took all that energy to be converted to get it to us. I like that idea. And the amount of primary energy compared to your final demand, well, what's that going to depend on? What's going to be the difference there?
Source, like what kind of hydro versus gas versus nuclear?
Absolutely. So it's going to depend on what conversion system you are looking at. And those are good examples that you just gave. If we use that old coal-fired plant that we were looking at in the previous slide, what's the ratio between the energy in and the energy out in a coal-fired plant? It's roughly 3 to 1. So there's about 3 times as much chemical energy in the coal that gets burned to heat up the steam than there is in the electricity that leaves to go up the wires to go and meet your needs at your home. Well, wait a minute, that means I need 3 times as much primary energy as I'm actually using on my final demand. Okay, that's quite a big difference. And if we contrasted that with hydro, you said, agreed it's a little bit of a simplifying assumption, but for hydro, they assume that the turbine is 100% efficient, converting the mechanical energy from the moving water into the electrical energy. That's not quite true, but it's pretty close. But it gives you a big difference between coal having a 3 to 1 and hydro being 1 to 1 ratio. Okay, I can understand that. What's that? You said nuclear we also use? What's the ratio for nuclear energy? Anybody know? So again, it's a simplifying assumption. So for nuclear, we say it's a big boiler. In fact, you get the same manufacturers of the big boilers. It's just a different source of heat. So they say it's really like a big coal-fired plant. So it takes 3 times as much heat to get that 1 unit of electricity coming out. So they don't actually take it to what's the energy contained within the uranium fuel rod, which is a different calculation again. To keep it simple, they say consider it the same as coal. It's about 3 to 1. And gas is a little better. So it depends on the system that you're using. Oh, now, if I'm thinking as a planner about meeting my energy requirements with a local source like solar panels on my roof, how is that going to compare? What are my losses going to be going from my solar panel to my house? What are those losses going to be like? If I'm thinking about going all the way from my roof to just under my roof, oh, very small. So again, we can assume it's like the 100%, so we don't have the big difference between the demand and what the primary source is if it was a coal-fired power plant, for example. So it makes it easier to achieve not only our American net zero requirement, but also our European passive house standards. So yes, local renewables are a good answer to both. That was a long talk. Okay, the same is true for other systems. This is the numbers for oil. Typically, you say, yeah, I just need a liter of gas to go in the car. But this is telling you, yeah, but there's about 20% more energy that was required to actually pump the oil out of the ground, process it in the refinery, and then ship it to you through the pipeline. So you really need 1.2 liters or of that magnitude. And yes, it does vary a little bit depending on the oil field and the technology. And yes, oil sands are a little bit more energy intensive, so the ratio gets a little bit higher. So rather than being, 1.15, it might be 1.25, or the exact number will vary. But it's of this magnitude. You need to think of at least an extra 20% to allow for getting it to you so you can use it. Any question about the difference between primary and final? It makes sense? So again, as good planners, yes, it's important to start here with the final consumption, but also think about the whole system and how much energy has to come in at the start. Yes?
Is that just like another definition for net zero, or does it have like a specific?
Well, the passive house actually says primary energy, so they actually use primary energy. So this is where we get talking about the adjectives. Is it final demand? That's just how many kilowatts are you using in your house? Or is it primary energy, in which case you need to adjust it for the system that is supplying it. But the passive house standard is officially in primary energy terms, and as an academic, I think that's very good. I know it makes life a little more complicated for your planners checking to see is it achieved, but we have techniques for doing that as well. Good question. But they actually use primary energy. Whoa, look at this, all these different sources of renewable energy. This is saying if we put in 1 megajoule, what are we going to get out? Whether it's wind, 30 to 60, hydro 30, here biomass 10, built-in PV. So look at how much energy you get out. For the US, for putting 1 unit of energy in, we get 0.3 out. Why do they only get a third of the energy coming out that they put into their energy system? They only get a third out because, what was that conversion from primary to final demand? Their coal-fired power plants are giving them about 1 to 3 ratio, or 30%. So that's what drives this. Another measure that we often use to look at it is the carbon intensity measured in either grams or kilograms per kilowatt hour. So the US number here, 990 grams, so that's almost a kilogram. So for a simple reference point, you can say 1 kilowatt hour of electricity emits 1 kilogram of CO2 if you have a coal-fired electricity generating system. It's roughly 1 to 1, so it's 1,000 grams. But to make life easier, we'll stop talking about kilograms and just talk about grams. Other systems have lower emissions. So if it's coal-fired like the US, it's going to be over 900, or gee, are there parts of Canada that are like this? Yeah. What parts of Canada? Places in Canada burn coal for electricity generation?
Alberta and Saskatchewan.
Absolutely right. So Alberta and Saskatchewan are of a similar magnitude. So 800 or 900. They have a few other sources as well, but primarily coal-based. So similar magnitude here. And then this is comparing the carbon intensity of wind, hydro, bio, and PV. So much lower. If you're talking about 50 instead of 1,000, wow, well that's going to make a difference. How big a difference? Oh, I remember Ontario. We were about a quarter coal, so we were about 300 grams per kilowatt hour. So that makes sense of that old 1 kilogram per kilowatt hour. So we were 25%, so we were about 300 grams of carbon. Take out the coal-fired plants, and guess what? We're under 100 now. So it varies, it might be 70, it might be 50, depending on the month or the year that you're looking at. But we've had a factor 5 reduction in the carbon intensity of our electricity. So that's a big change. Well, but why is there still carbon in here? Why didn't it go to zero? Any thoughts? Why not to zero? Is because we actually are although the coal we closed, we brought on some gas-fired turbines, so we still use some gas in our system. So the amount of gas is also being decreasing, but that natural gas burning means that there's still some carbon in our system. If you're driving to Toronto through Milton, you see the big power plant on the left-hand side there, and so that's a gas-fired power plant. Gas-fired power plants, we call them peaking plants. Why do we call them peaking? We tend to talk about base load and peaking.
Sorry, I was like in your class, so I feel like I'm cheating. But
Well, but it's good that you remember. Now that's a plus. I like that.
it's because usually they turn them on for like peak hours, like they run on nuclear and I guess also hydro, I think, for like the majority of the day, and then when it bumps up, because it's easier to turn the gas on and off, it's more efficient to do that than anything else.
Absolutely right. You could give this lecture. That's perfect. No, that's exactly right. We have base load to establish the ongoing base. That's exactly right. And for that, we are typically using our nuclear. As well, nuclear only changes very slowly, so you can't ramp it up and ramp it down quickly. And in our case, hydro is also very good for peaking, but because Niagara Falls is really cheap electricity, they like to keep it running all the time in power plants out in Niagara just to help lower the price of our electricity. And so when things get high, that's when we'll introduce the natural gas peaking plants. Oh, time to get back to topic. Yes, Professor, tools I promised. The easiest tool, of course, why don't you use what other people are using? If you go for the standard tool, you'll use the same standard spreadsheet. And so this is Partners Climate Protection. So the Partners for Climate Protection have been adopted. This is the Federation of Canadian Municipalities program, but guess what? It's exactly the same as the ICLEI program. ICLEI was that International Council for Local Environmental Initiatives. So there is a standardized system. And so these are some references for you. There are, of course, many municipalities of Canada have already participated, so you can look to see what has your community already done. If you want to look at the reports and what the standard 5 steps are, that's available. And there's a good standard spreadsheet to start saying, okay, how many buses do you have? How big is the fleet? You know, what are the wastes that you're dealing with? So standardized compartments. And so this is sort of a standard municipal planning tool. And if you are involved in an energy plan or a climate action plan, this is probably the framework that your community would be using. So many of our communities have, and it gives a consistency that way. So this is a good tool to be thinking about. It has 5 standard parts. The first, of course, is having an inventory. So what are you currently using? What are the emissions? The second is, okay, what's your target going to be? Are you going to say, oh, just a little? Or are you going to be more ambitious to say a lot? What's the plan to achieve your target? You need to implement your plan, and then you need to measure and monitor. Are we on track for achieving our targets, right? So it's very simple, standard, that you would have seen similar models in any strategic planning process. This one just happens to be energy or carbon focused. I said carbon really meaning CO2 equivalent, because what is one of the biggest wins that communities often get with this process? One of the first areas, the biggest reductions they get, is actually not so much CO2, but what's an even more potent greenhouse gas? Methane is about 25 times more potent, so one molecule of methane has the impact of 25 molecules of CO2. Many municipalities have waste landfill sites that are emitting substantial amounts of methane. So one of the biggest secrets in the municipal world is just capture the methane and burn it. You can generate electricity at the turbine that gives you revenue, and you have a much lower greenhouse gas emission because it's carbon dioxide rather than methane that's going into the atmosphere. Anybody know where we could find such technology? Have you been told about it in your other courses? You should have. This is one of the most important and easiest steps. It doesn't cost very much either. Yes, I know, it's how Vancouver eliminated like over 20% of their, or achieved over 20% of their emission reduction, by far the biggest thing that they did. But one of the early communities going there was the region of Waterloo. Just go up RetScreen. That's exactly what we're doing up on Earth Street with the landfill site up there, capturing the methane, burning it so you convert it to electricity before emitting. It's one of the most important steps, reduce methane emissions. And if you're tired and late at night wanting to see scary methane videos, methane becomes really important, and a lot of methane has been locked in our northern permafrost and the bottom of the lakes, and as it gets warmer and the ice melts, the permafrost melts, there are pictures of crazy people on the internet. I know you know this far better than I do, but to me it's scary to see the crazy person go out with the big bar, stab a hole in the ice because it's been warmer and the permafrost underneath has been melted. And what happened? A friend had a lighter and this great flame comes up. It's methane that's being captured under the ice, released from below, captured by the ice. As soon as you put a hole in the ice, you go, whoa, I think we have methane emissions now. You know, this is you know, it's just figurative, but it just shows all organic matter when it's, you know, this is the whole, how do you manage your waste? This is very important. Just as how do you manage methane with your livestock is important. And that's one of the metropolitan secrets. Waste management is important. Agriculture, transportation, workplaces, homes. These are all examples taken from our local Waterloo region. This is the local inventory, 3.6 million tons in our base year of 2010. What we want to do is reduce that number. How ambitious should we be? How big a reduction would you like? You're planners. The City of Waterloo actually has a sustainability coordinator participating in these plans. How ambitious should we be? Do you know how ambitious the official plan is?
6%.
You're absolutely right. Yeah. 6% reduction. I must confess, I failed in my participation in the community consultation because I was obviously arguing for a more ambitious number. But our ever balanced, planning students argued for what? Achievable goals. And so, of course, it's better to be going down than going up, and we are in a growing region, and so the 6% absolute actually represents about a 25% in terms of the number of people and the intensity of the economy. And so, yes, that's good, but it's not going to get us to where we need to be. So, at least it's finally turning in the right direction, and 6% is exactly right. I wish we were more ambitious, but are there more ambitious municipalities around? Anybody heard of this radical place called Stratford? Stratford is in Oxford County. What? Oxford County? Yeah, that's where all those cornfields are, just south of here, right? Big flat farming country. What's Oxford County's plan? Waterloo, big, high-tech, all-powerful. You know, they say the Waterloo economy is bigger than the economy of the province of New Brunswick, right? So what's our little neighbor Oxford doing? Come on, you gotta want the most exciting planning job in the region. What is their official target? 100% renewable. Whoa! 6%, 100%. Which would I rather be working on? Hey, sorry, you get my bias here. So not all municipalities are having the same target. They have different reasons for different strategies, and different places will, have different ambition levels. And then we'll see how they make out in getting there. These are examples of the actions. You were talking about transportation last week, so you already know about that. That's great. How many fuel cell buses are in the fleet? That's right, none yet. So we need to keep working on the future. Of course, the cheap one is in the middle. That's actually improving our efficiency. And then plugging in electrification. How do we stop burning gas in our cars if we use electricity? And remembering, electricity can be low carbon or it can be high carbon depending on the source. So what is going for electric vehicles a low carbon or a high carbon option here in Ontario? Is it a low carbon or high carbon option here in Ontario? Is our electricity?
I'd say low carbon because there's no more coal power plants.
I think you're exactly right. That's exactly the conclusion I want you to make. And if you're out west thinking, should I get an electric vehicle or not? My question is next. Which side of the Rocky Mountains are you living on? If you live in Alberta, is it a good idea to switch to an electric vehicle? I mean, it might be if you like electric vehicles, but it's not going to reduce your carbon emissions because you've got coal-fired electricity, so you've got carbon-intensive electricity. But if you're in British Columbia, now you've got low-carbon electricity because it's from hydro sources. So even in the same country, depending on which side of the mountains you're on, you get a different answer in terms of, is this an effective carbon reduction strategy? It depends again on how carbon intensive your electricity is. Or if you want to report back to the mayor what a great job you've done. Hamilton was one of the first to participate in this process, right? They came back to the mayor a few years later and said, yes, we met our target. How are they so good at making their target? The province of Ontario had cut the coal-fired plants out of their electricity, so all of the electricity that the city was consuming was now low carbon. So you can say, hey, don't you look good? It actually had nothing to do with what the city of Hamilton, I should be fair, they were making other steps, but their biggest reductions, their biggest claim to achievement was actually done by the province. But of course they counted in their calculations because you look to say how carbon intensive is your electricity. So these are different examples of action plans, lots of good things to be done. You get different organizations involved. Haus for Sustainable Living. Anybody been there, seen that? So, what's it about?
So it's just a house they built in downtown. Well, not they built, they restored. I think it's a heritage house that they restored to become a LEED certified house.
Absolutely.
They have things like rain barrels in the backyard, solar roofs, and they showcase all the new technologies.
Exactly right. So it's how do we convert the old lifestyle to new? And there are multiple agendas here. I confess I was focusing on energy, but I also love getting good planners and designers in because this house has been transformed over the last 100 years. Remember, when this house was built, there was no internal bathroom for it, right? Huh? Yeah, you had things called outhouses for a reason. And so when they put a bathroom in, they just cut a corner out of the bedroom. So you had a little pokey bedroom and even pokier little bathroom. And so it wasn't the most attractive. It's small, it's a bit cramped and pokey little rooms. And you're trying to say, but I'd rather have people living downtown close to amenities and transit rather than building these big houses out in suburbia. How do we make this old house perform like a 21st century house, but actually feel like fun to live in? Bring in the designers. Two favorite ideas. Number one, rip out the walls. Huh? Yeah, the hallway was wasting a lot of space. Now you've got a much bigger living room. Or, my favorite, upstairs, how do you make that pokey little bathroom bigger? Get rid of the ceiling. It's volume that counts, so the floor space isn't so big, but it feels much bigger when there's no ceiling. I see right up to the roof, So good design ideas. Academics are not necessarily the best designers. We were saying we've got to respect the brick on the outside. We're going to have to insulate on the inside, and the stairs are right hard against the wall. How do we improve the performance of the wall without in such a little space? Oh, I know. The Germans, they've got these special vacuum wall panels that have very high thermal performance. Just don't punch a hole in it. Okay? So no pictures on this wall. And so we were thinking, yeah, we could get one of these thermal panels to go in. And then, of course, we brought in the builder. Owns, he's been working in a few heritage homes like this. He goes, yeah, where would you like the stairs? I can move them over for you. Yeah, if you can move the stairs over 6 inches, we got 6 more inches of insulation that we can kind of avoid that really expensive vacuum panel coming all the way from Germany. Invite a few practical people in on your team as well. It's a good idea. So yeah, with good ideas from many people, we achieved the 86% reduction. And here's our energy evaluator, and to give you the options of choose what insulation you want and what the annual heating cost would be. So again, it's public information. I do confess, the basement is a scary place. Most people find basements scary places, and we have too much technology in there precisely because it is a technology showcase. You would choose a system for your home rather than all these systems. We're not advocating you have all these systems, that it's an educational place. But what's that about climate action? It does what? It builds your local economy. Huh? I love, what's our favorite Canadian city story in terms of environmental leader? Who wants to be the greenest city in the world, and who do we often look at? Canadian cities, famous Canadian cities, environmental leadership. Who likes to brag just a little bit? Okay.
Vancouver?
Absolutely right. Vancouver, and what was their secret in terms of wanting to continue to grow their population and economy while reducing their emissions? What did those clever planners in Vancouver do?
They did a few things.
They did a few things. Do you want to share any with us?
They've improved their public transit system. They've increased density targets, and they have very strict boundaries on their urban growth. They have very strict urban growth boundaries, so they're not allowing the greenfield that we're seeing in this region in particular.
Yeah, and as part of their density planning, though, they say we are only going to let you convert to a multi-res if you build to a higher performance. So actually, the Vancouver building code is more stringent than the provincial code. Most municipalities just say, yeah, we'll do whatever the province tells us. Vancouver was one that went the other way. He said, no, we're going to have higher standards here. And why? Because it creates jobs. Because if we have people that are making the technology for higher performance building envelopes, guess what? The people that are going to be installing that, or they're going to be making the windows, that are going to be installing the windows, if you're going to have triple glazing, or they're going to be adding more insulation, these are all local jobs. A piece of technology, like a furnace might come in from overseas, but all of this building work on the building envelope, this is labor intensive. This is you and your neighbor doing this. So it helps build jobs. And so this is part, of course, of the Vancouver success story. It's also, if you look at California, leading green jobs location in the US, 70% of their jobs are in energy efficiency. This is the big place where you gain a lot of jobs as well as improving energy performance. Get the people involved for your implementation strategy so you can move along. This is a little bit of the success story. Over time, our houses are using, yes, 14% more energy, but there are 33% more houses, and the average house is getting bigger, so we've actually added nearly 50% more floor space across Canada. So the good news is housing is getting more efficient, but because we're having more and more houses, we're still increasing our total demand. Tool time. What's this? What's this tool? This is the tool that I confess I was at the school playground when the neighbor says, oh, I'm so excited, I got 79, and that's really good. And she says, and if I go to another house, how will I know that I get at least as good a house, at least a 79? And the answer is the EnerGuide for houses rating system. Just like we have EnerGuide ratings for cars and appliances, this is the EnerGuide rating system for houses in Canada. It was introduced with the idea that you want to be an A student, you want to have an A house, so you want an 80 as your score. Okay, I want a grade 80 equals R2000. If I don't have any commercial energy, I'll be 100. I'm perfect. Oh, that would be nice. And then it's a linear scale, so if your house consumes two times as much energy as an R2000, it would score a 60. 3 times a 40. 4 times a 20. 5 times a 0. And how low can it get? We have actually scored negative numbers with this system. But the homeowner was protected. The computer didn't want to print out negative scores, so the sticker that we put on their electrical panel didn't tell them. So it didn't give them away, but it means there are houses that will consume 5 times as much as one that's built to an R2000 standard. What is the R2000s? That been covered before? No, all planners would know. This was developed, so it's Canadian standard, developed starting in the 1980s, again after the energy crisis, saying by the year 2000, we'll be building more efficient homes. So they developed the R2000 standard. And it was a voluntary program. The government trained over 700 builders across the country who could build to it, so wherever you were, you could have it built. By the year 2000, how many houses were being built to the R2000 standard? Good planning, promotion, information systems. Was it 50% of the houses? No, maybe not. 40% of the houses? By the year 2000? We've been talking about this since the 1980s. By the time 2000 came along, 30% of the houses? Nobody's joining me. 20% of the houses? 10% of the houses? 5% of the houses? 2% of the houses? 1% of the houses? You know, this class is better informed than some. That's right. We were having about 1/2 of 1% of the houses built to the R2000 standard. It was a good idea, but because it was voluntary, not many people bothered with it. Oh, that's kind of disappointing. How many houses are built to the R2000 standard today in Ontario?
They adopted as part of the building code.
Oh, you are a good listener. Absolutely. 100% now. Because the province adopted it as a building code, anything else would be illegal. So now 100% of the new houses are. So this was a good test between the voluntary and the regulatory approach of introducing programs. So yes, now 100% of our houses are built to the R2000, and we can say let's make them even better. But it's an interesting experience over time. Huh? EnerGuide. Oh, wait a minute, this is a different set of numbers. This goes above 100. Yeah, just as soon as we got everybody educated saying we want you to aim for 100 on your EnerGuide scale, you're lucky. This is the year Canada changes. You used to want to score 100, now you want to score 0. Pardon? Yeah, you used to want to score 100, now you want to score 0. So they have reversed the scale, and in part because our Americans were adopting a scale similar to this. So now what we want to do is to push down that new house. Remember I said 100 gigajoules? And can you get down to 0 to have a net 0 performance on your house? So just as soon as we trained you what or train the public about what the EnerGuide scale is like. Now we have to say, actually, we want it to go in the opposite direction, and you need a new number instead of your old number. But it's important to have a standard for comparison. Just remember that we now have a new scale, so yes, you've got to think about it twice. Is that number on which scale? Now we want to aim for 0 to be consistent with our net zero talk before. Yes? Sure.
Why does it say this house has significant energy uses not included in the rate at the bottom?
The government does not have control over your TV. So the government looks at the standard energy performance for space heating and water heating. And on electrical devices, it figures we don't have a standard. One Canadian has a little tiny laptop that they're using. The next has a giant plasma TV. So even in things like home entertainment, we have big differences. And officially the answer is that people take their devices with them. So it's not a feature of the home. If you sell this home and go to the next, you'll take either the big plasma TV or the little laptop with you. So it's more about personal choices. For big things, they've made standard choices, like to rate a clothes dryer. They assume there are 4 people, each doing 2 washes a week and so on. But it gets harder the more electrical things you look at. So they're just saying all those little things, those are personal choices, and they're not included in the model. But good question, good question. So these are the big 8 retrofit areas. I'm going to go through these pretty quickly. You can add insulation in the attic, the walls or the foundation, improve the windows and doors and air sealing, upgrade the heating and cooling system, upgrade the water heating system, and once you've done that, you want to install a heat recovery or energy recovery ventilator so you have good quality fresh air in your house. This is just showing the different climatic zones, so there are different standards. How much insulation? My advice is listen to John Straub, our engineering colleague. If you want advanced performance building, he says, okay, R20 in the basement, R40 in the wall, and R60 in the attic. So a simple 20, 40, 60 rule of thumb. These are a little bit different. So this is R40 in the wall, R25 in the basement, and R60 up top. But it's of that magnitude. Some people go, oh, but I could put R100 in. And you go, yeah, you could. You just fill the whole space full of loose cellulose and can have it there. But Canadians have been very good at insulating their attics. So if you look at heat loss in the different parts, our attics now typically lose very little heat. We're going to have more loss through air leaks, through the windows and doors, through the walls and foundation. And so these are areas where we can make improvement. This is by when the house was built, so you see the Second World War, suddenly go, oh, wait a minute, if we insulate the wall, we'll lose a lot less heat through the wall. So this just shows, and this is based on the first 1,000 houses that we evaluated with the REAP project, so this is local data. Pictures, standard 2x4 construction, pink bats in between. They say, oh yeah, this is our 12 insulation, but actually the 2x4s act as a thermal bridge, so it drops it back to only R10 actual performance. We want to avoid the thermal bridging. One way of doing that is putting the rigid extruded polystyrene foam over top. Oh yeah, that's why these houses, when you look at a new subdivision, they turn yellow or pink or blue, depending on the color. This stops the thermal bridging of the studs. Or you can do the same thing on the outside, so it's continuous. There are no studs here. How do you hold on the cladding on the outside then? Metal strips that are just screwed into the main concrete wall. So it's minimizing thermal bridging, maximizing the area of insulation, and I love my most boring photograph from this building downstairs in the ground floor, and when the lecture theater was being built, because they had continuous insulation behind the studs. So this is the type of construction that, oh yeah, EV3 has. I like that idea. Of course, you have air leaks when the wind's blowing, or the stack effect as hot air rises, and you can look at all the different places where you can have air leaks out through the house. The biggest problem area is right at the floor joists And so this is one that very few people look at, but an easy solution is foaming in the floor joist, and go in the basement and look up. It's sort of a place where nobody ever looks, but it's often one of the leakiest places in terms of air leaks in a house. And so tightening that up can help the performance in your house. And it's where we had the biggest change that people just didn't know about or think about it before. Oh, that's pretty good. Our European friends, again, would talk about the global warming potential of the expansion gases. And so it's important to know what gas they use for expanding the foam. Some of them have a high global warming potential. But then, wait a minute, what would that Quebec company do? They're using water vapor, so very low. So different gases will have different carbon effects. Having a nice tight house, we now need to add in our mechanical ventilation so we keep the heat and keep fresh air for good air quality as well. Sealing around windows, the performance features of windows. We now want to have triple glazing as our standard. The sunlight comes in, they're low E coated so that the infrared heat does not go back out. So it stays inside to keep you warm. So we have low E, and then we fill in the gap with argon or krypton so that our windows have better thermal performance as well. This is a comparison. We're going to do program analysis. The more recommendations, the more actions people took under the EGH program. That's a good thing. The more actions they took, the bigger their improvement in terms of points on that EGH score again. Another good thing. And EnerCan provides the Haus as a system framework that is a good place for any reading you want to do on this topic. While it's easy to say that it's free, I prefer to say you have already paid for it with your tax dollars. So go ahead and use it. EnerCan, energy efficiency, home improvements, keeping the heat in. This is a slide that looks at carbon intensity that says those hot summer days is when our electricity is the most carbon intensive. And as a result, graph of consumption in Milton homes, that the carbon intensity is much higher late in the day because this is when those peak gas-fired plants have come on. So the carbon intensity is much higher. Where else could we get our electricity in sort of a bright sunny afternoon, I wonder? Oh yeah, those solar panels are quite well timed too because we have become a summer peaking system when our air conditioners are on. And our air conditioners come on those hot sunny afternoons, and with that sunshine up in the sky, I bet it could generate some electrons with those PV panels too. This is looking at the AC circuit, far more spiky, right? So just look at that, put on the AC, solar powered AC to make it low carbon. Thank you. This is all details. You've got working with engineers, got lots of toys. We can measure every circuit. Do people do anything with this? No. What? We've got all this information. Not interested. But you could schedule it, you know, and they don't bother participating. But we can make it like a budget for our different appliances. How much electricity is going to your fridge every? Nah, not interested. Oh, come on, we've been working hard. No, not going to do it. Okay. How about if I give you $100? Will you let the computer decide when the thermostat should change now? Oh, just for this week? Okay. Of course, in the qualitative survey, people said, oh, you didn't really need to pay me. But next week, they turn the computer off and say, I'm in control of my temperature. So the social side is just as important as the technical side here. But what did work was feedback. People love knowing what their neighbors are doing. So suddenly you say, look what you're doing. This is the average. This is what the best houses in your street are doing. Be one of them. So go for the social comparison, and that's where people would make a lot of improvements in the discretionary areas. Wow. We have the tools. We have the people. I think it's time for a change. Community energy planning. I added a section on the north just because I love bragging about it. Why? Where is Canada's leading solar jurisdiction? Where is Canada's leading solar jurisdiction? It's obviously a leading question. You think Ontario, we've got all of this PV that's come on. Sure. Ontario's big, but that's just because we're big. Who's the most ambitious? The Northwest Territories is the leader in Canada. Pardon? They did an experiment with Fort Simpson. They put in solar panels to generate 20% of the electricity. The project came in on time, on budget, and generated even more electrons than promised in the first year. Well, if you're the planner evaluating that, guess what? Say, let's do it for every community across the Northwest Territories. That's what they're doing. And they say, while you're at it, can we go to 75% instead of 20%? So they're looking at all of their remote communities, 20%, go for it. Wow. Change your community. Either in the south, the north, we have the tools, go to work. Happy to answer any questions, and I'm happy to stay a little bit after class if people want to follow up on any questions. Thank you very much. Sustainable communities.
Questions?
In relation to one of your last points about benchmarking and social comparison, why isn't that more common where you know how much energy you're using?
Privacy, right? It's why, like, we had to get everybody that was participating agreed. And of course, we say we're not giving names about, we're not pointing fingers to say that's the house that's consuming more. We just do the analysis. And I like simple analysis, so just quintiles, just 5 different groups. So that way you know, are you in the bottom 20% or the top 20% or in the middle? And people actually responded to that, right? Suddenly going, oh, wait a minute. I like being there. And because they suddenly go, I can do my laundry on the weekend. Then I've got 0 laundry in the peak hours because the weekend's all off peak. And so where you had those discretionary loads and social norms, that's where we saw the biggest change. Other things, a lot of it was, no change, or actually, I got a new toy that's going to use even more electricity. So even some of our participants were increasing their electricity consumption. But where they had discretionary loads, they wouldn't move.
I think if you have like a nest, you can like see other people. Like if you look like if they let you kind of thing, and then you can kind of like compare.
And this obviously is a big game at the moment, and all of the companies want to position themselves, say who's going to have the technology that people will use in their homes, and everybody, Google realizes that this is going to be a potentially big market. Lots of players trying to be able to say cars. Any other questions?
This is like on the East Coast and they don't have natural gas. Like, do you know what the split is like for their renewable?
Yeah, it's not as good, but the East Coast, I'd love to change there. What is the now low-cost way of heating your house? If you're building just even the low-cost housing in Nova Scotia and New Brunswick, they're using air source heat pumps. They're cheaper than furnaces. And oh yeah, what was the ratio? I talked about it takes 3 units of coal energy to get 1 of electrical to you. A heat pump takes 1 unit of electrical energy and gives you 3 units of heat. So the houses that used to be electrically heated, now they can cut their electricity consumption to a factor of 3, so cut it down to 1/3. So heat pumps are really taking off because they're low cost. And you have more furnace fuel oil being used because you don't have the natural gas access the same. That's cool.
What's generally your response when you hear people that are arguing that solar panels, the waste they generate, cancels out their benefit? I'm not saying I believe that.
No,
I just have heard that
absolutely.
argument.
Well, the first is it's a really old argument. So like it was true back in the 1980s that it would take 4 years of operating your solar panel to offset all of the energy that it took to make it. But the manufacturing has become much more efficient. So then the 4 became 2 years. 2 years became 1.5 years. Now it becomes a year, and it depends on how carbon intensive your panels are. But wait a minute, my main story, the thing that as planners I would encourage you all to think about life cycle. The beautiful thing about solar panels is they can be working for 30, 40 or more years. It's not like a cell phone that you're throwing away next year. So it is much easier to recycle materials when they are in a larger quantity. And certainly the longevity, again, my Northwest Territories story, when were the first panels put in the Northwest Territories? There's a 1983 installation. So they've been working in the Northwest Territories Yellowknife since 1983, currently operating at 70% of their rated output. So it's true, it's not 100% anymore, but they've lost like 1% a year over 30 years. And you go, wait a minute, there's no 30-year-old car on the street in Yellowknife that's performing to that level. So the solar panels are two things. One, the industry has become much more efficient, and two, their longevity is much better. Why? Ask how long your gas furnace is going to last these days. I mean, burning fossil fuels is very easy, but we now put cheap electronics on, so they only guarantee it for a few years, and then the electronics give out, so they have to put in a whole new unit. So please, in terms of planning, if we can think of longer life expectancies, that's great, and especially in our built environment, because you're building communities and housing to last for generations. Good question.
How do you see the regulations and bylaws in Canada in terms of in the federal methodology for buildings?
So you've all, as planners, you all know what was the biggest change in the Ontario Building Code? It went from being prescriptive to being performance-based. This, I think, is one of the most important changes. We used to prescribe, how do you build a house? They would say you put this many 2x4s for strength, this much insulation for thermal performance. So there was no innovation. There was only one way of doing it. Now they say, I want you to achieve the R2000 standard, and you can choose the best way of doing it. I think that is excellent. Set the performance and let the industry innovate. So my advice is to say my performance target is net zero. I want to let the industry experiment to say what is the best way to achieve that. So I really like this change from prescription to performance-based standards. Thank you all very much.